Chapter 9, Chapter 10. Okay. Chapter 9 called Electronics. The first subtopic that you learn is called Cathode Ray Oscilloscope. Okay, CRO. Now, cathode ray oscilloscope, you will learn this thing here. Is like something like an old technology juga lah, okay, right? Kalau you tengok sekarang kalau you tengok TV, isn't it your TV semua like flat TV, isn't it? Flat TV or okay, okay lah, I show you this one lah, okay. Now your TV is all flat, but then you never seen before maybe, or you know about this, but you maybe no more using lah, okay. It's called CRT TV, okay, CRT monitor TV, CRT like that one. Kalau komputer yang macam ni, okay, right, CRT punya monitor, yang belakang dia ada bonjol kan, okay, this computer monitor, okay. TV pun kan ada bonjol belakang, right? CRT TV lah, ni CRT monitor, CRT TV. TV yang belakang bonjol kan, ada bonjol belakang. Right? CRT stands for cathode ray tube. Cathode ray tube is similar to what you're learning now, okay? But now we call it CRO because the difference of CRT and CRO is CRO only uses one color or one electron gun. Okay, dia ada satu electron gun je. Okay, but this CRT tadi, they uses 3 electron gun. Okay, the electron gun got 3. Okay, dia ada 3. So dia ada 3 color kat dalam. Okay, dia ada 3 color nanti. Right? That's why tengok TV, tengok monitor ada 3 color kan. So they got 3 electron guns inside. Okay, more complicated than what we are learning then. Okay, we are only learning CRO. Okay, so this inside of TV there. Saw it or not? Okay, this thing. So, right? This electron gun. It looks like a gun juga kan? Right? Okay, what I want to say is, what else? What else to tell you? Just now suddenly remember to tell you something. Okay. I want to show you CRO. Okay. Siap, ini apa ni? Okay. Sorry, oscilloscope. This machine, okay? This machine. Now, this machine here, okay, now should be more advanced already, right? But then this is the one that you're going to use, you're going to learn. Okay, a lot of buttons here and there. The screen is there for the graph, right? So the behind part, the inside one, you see the box rectangular shape, right? Inside there is what you have called the thing like this, this thing, okay, right? This thing, okay? So we're learning the thing behind it, understand? The screen is here, the screen, the green color here is the screen. So screen is the one that you see the graph, and understand? So the longish thing here, the long thing here is actually the behind part of your CRO, the behind one, the belakang dia, boleh? Ni benda ni ada kat belakang dia. Understand? Kat dalam dia lah dan belakang dia. Boleh? Okay. Now, so parts dia kena ingat, kena hafal, okay? You have to hafal all these parts. Once you hafal, then you need to also know the function of each of them. Okay. Right. Okay, first of all, need to know that this CRO consists of 3 parts. One is called the electron gun. Another one is called the deflection system. Last one is called the screen, the fluorescent screen or screen. Okay? There are 3 parts of CRO: electron gun, deflection system, fluorescent screen. Okay, the electron gun consists of the heating element first, the heating filament. Okay, the one that coil kat sini, right? Okay, then after that, the cathode, this piece of the rectangular thing here, the cathode. And after that, in front is the control grid. Okay. Then in front is the focusing anode. And then after that, the accelerating anode. Okay, so those are the things that they have. Okay? For electron gun. After that, the deflection system only got 2 things inside: Y plates, X plate. Okay, and then finally, fluorescent screen then. Okay, now let me explain to you how this thing works, or what is this. Okay, it's like this. First, you switch on the CRO. Okay, once you switch on CRO, okay, the CRO you switch on, they will cause the electrons to start to flow, the electricity start to flow into the heating filament, right? So the heating filament become hot then, correct? So it's heated up then. So once it's heated up, they will heat up the piece of cathode here. Okay, the piece of cathode plate here. Okay, this cathode here is actually just a piece of metal. But why is it called cathode? Because it's connected to the negative terminal of your EHT. Okay, EHT is extra high tension circuit, right? Isn't it? The high voltage one. Understand? Okay, so here already got electricity coming in. Here also will have electricity going into the anode and the cathode. Okay, right? That's why you see the picture just now got many buttons here and there. Okay, right? So right, but this one is a simple picture of what is inside. Okay, so why is this called a cathode? Because it's connected to the negative terminal of your EHT. That's why called cathode then. Why is this two called anode? One is focusing anode, one is accelerating anode, because it's connected to the positive of your EHT then. Okay, right? Okay, now start with the cathode again. Okay, again, you on the CRO, electrons start to flow, heat up the heating filament, right? Once it's heat up heating filament, it will also heat up the piece of cathode here. Okay, once this piece of cathode get heated up, the surface in front of it, the permukaan kat depan dia, akan start to keluarkan electrons. Okay, bila panas dia keluarkan electrons. Okay, because the electrons get excited, the electrons have enough energy because it's heated up. Okay, so once the electrons get excited and they are heated up, so they become able to move. So therefore, they will move to the screen then. Right, they move to the screen. That's why you saw the word here called electron beam then. Okay, they start to move to the screen. So whatever you see on the screen is actually electrons coming and striking the screen. The electrons datang dan terkena pada screen lah. Kan? So mana electrons datang? Dari cathode. Bukan dari heating filament. Heating filament is to panaskan the cathode je. Okay? Panaskan the cathode. Then you might say, teacher, how come the electrons go out, never end? Because you still on your EHT, isn't it? So the electron actually come from that EHT circuit. It come to the cathode, continuously coming. But then you heat up, then the energy become higher and higher. That's why the electrons able to come out then. Understand? Okay, on the screen. Okay, now in front of the cathode, there's something called a control grid. They forgot to label it. Okay, they forgot to label this. That's why I wrote that control grid sana. I baru perasan dia forgot to label that. It's called a control grid. Okay. I ambil gambar ni dari Google saja sebenarnya. Okay. Now, control grid, you control it from all these buttons. One of these buttons. Okay. Find for the button, they can call it control grid or they call it brightness. Brightness, okay. Kalau you tengok TV ke, you ada boleh adjust brightness kan, your screen laptop pun boleh adjust brightness kan, your handphone punya screen pun boleh adjust brightness, isn't it? So therefore, this control grid, you adjust the brightness actually. Okay, so control grid actually do what? Is to control the amount of electrons that will strike the screen. If you want more electrons pass through, then it will be brighter than nanti. Less electrons pass through, then it become not so bright then. Understand? So that's the function of control grid. Okay, the notes are all there actually, but let me explain first before we read together. Now, once they pass through the control grid, they have to pass through another thing called focusing anode. Okay, focusing anode here is to focus the electrons then, focus the electron beam. By the way, this electron beam got another name. Okay, electron beam also known as cathode ray. Cathode ray, sinar cathode. Kenapa? Sebab electrons tu datang dari cathode kan? Isn't it? The electrons berasal dari cathode. So since berasal dari cathode, we can call it cathode ray as well. Cathode ray ataupun electron beam. So electron beam is also cathode ray, understand? Now, okay. Bila dia keluar, it's called electron beam or cathode ray. They have to pass through focusing anode first. Focusing anode, after control grid, focusing anode is where they focus the electrons into one straight line. Because if not, too much electrons coming out, then later become all around the screen. So you want it to become one point there. So therefore, this is to focus it. Okay, right? To focus it to become a beam then. Kan? Think of this like a convex punya lens then. Isn't it? Convex lens focuses the light, kan? So this one they focuses the electron then. Okay. So this thing called the focusing anode, it acts similar to a convex punya lens then. Huh? After focusing anode, there's another anode called accelerating anode. Okay, accelerating anode for sure is to accelerate the electron beam, isn't it? Dah nama accelerating anode. So they accelerate the cathode ray ataupun the electron beam. They make it go faster, understand? Okay, they make it go faster. Okay, but my question is, okay, now let's talk about accelerating anode. The accelerating anode. My question for you, okay, I hope all of you try to answer. Are they making the electrons or the cathode ray, okay, accelerate? You all know what is accelerate, right? Pecut, go faster and faster, kan? Okay, cathode ray accelerate from cathode. We start from cathode, kan, to accelerating anode, or is it from accelerating anode to screen? Okay, that's my question for you then. Which one? Is it this one or is it this one? Okay. One more time. The function of accelerating anode, okay, is to make the cathode ray accelerate, correct? Okay. To make it go faster. From where? From the cathode to the accelerating anode ataupun from accelerating anode to the screen. Which one? Satu je jawapan ni. Let's call the first one as number 1. Let's call this as number 2 then. Okay. Number 1, number 2. Others? Try. Everybody try and think. Answer, sorry, not think. No need to think so much. Just to like make sure you are also there. Others? 1 or 2? Remember, 1 is cathode to the accelerating anode. First one. Second one is accelerating anode to screen. Google want to be a bit different. Others? Two people become one. Some more. Others? 2. Others? Some more. Few more people. 2 or 3 more people answer, then I give the answer. 2. Others? Okay, one more answer from somebody. Anybody? 1 or 2? One more person je. Just one more je. 1 or 2. Right? Okay. Manlok follow Kugan. Okay. How many here? More people answer 2, 3 people answer 1. Okay. Now, the answer is this one, the second one. The second one. Okay, not the first one. Sorry. The first one, not the second one. The first answer. The first one. The first answer. Okay, the first one is correct. The second one wrong. Okay, right. So number 1. Okay, right. Okay, 3 of you correct. Okay, good. Now, okay, let me explain why. Because of, oops, sorry, what happened? Because of this, always remember that the accelerating part happens from cathode towards the anode. because cathode is negative plate, anode is positive plate. So positive attracts the negative, then dia tarik. So positive tarik negative. So when the thing pulls or tarik, it tarik become meaning got force there. So when got force, sure got acceleration, isn't it? F equals to ma. Understand? But from here anode to screen got no positive negative sign. So this one is actually going constant velocity then. So here initially the electrons are at rest, velocity kosong. So dia semakin laju. Jadi 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 katakan. Then 15 all the way then. Dia dah capai maximum velocity dah. Boleh? Okay. 0, then become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, then 15 all the way. Understand? Okay, so remember here is constant velocity. Because if this one keep going accelerating, then hard to deflect them nanti. This one is a deflection system. You need to make sure it's constant velocity, then we can deflect properly then. So the acceleration happen here, understand? Okay, question do ask before one. They ask you, describe the motion of the electrons from cathode to accelerating anode. And then from accelerating anode to screen. So you need to say here to here is accelerating. Here to here, constant velocity ataupun acceleration equals 0. Huh? Okay. Now, once past this already, they pass through Y plate, X plate. Y plate is to deflect the electrons up and down then. That's why they panggil Y plate. Dia atas bawah. Perasan tak plate dia atas bawah? So it causes the electrons to go up or go down. Okay. So when you see your graph, kan ada atas bawah kan? Atas bawah, right? So the atas bawah, that one is actually caused by the Y plate lah. Understand? Then the X plate is the one that deflect the electron kiri kanan of your screen. Kiri kanan. So that one actually give you the axis of time then. This one give you the axis of voltage then. This one give you the axis of time. Understand? Kan ada graph nanti kan? Graph macam-macam lah. Okay. So these two are the deflection system then. So Y plate is to deflect electrons or cathode ray vertically. X plate is to deflect the electrons or cathode ray horizontally then. Understand? Okay, fluorescent screen. Fluorescent screen, the function is to convert the kinetic energy of the electrons into light energy. Isn't it? The electrons are moving, so got kinetic energy. After that, hits the screen, become light energy. So fluorescent screen is to change the kinetic energy into light energy. Boleh? Right? Okay. So number 2, heating element. What is the function of heating element? It heats up the cathode. All this I already tell, just that I want to make sure everything told. Okay. It heats up the cathode to a high temperature, roughly 1000 Kelvin. Okay. Right? Which is like roughly how many Celsius? Yeah? Kelvin go Celsius, isn't it? You minus 273, right? Roughly 727 Celsius then. Okay. Okay. So high temperature there. Why? So that can heat up the cathode. Okay. And then since they need to heat up, so the heating element usually we use nichrome or tungsten. Why? Because they have high resistance to produce more heat and high melting point as well. They are having high heat, yes, because they are high temperature, so they need to be high resistance, right? Okay, and then they need to be high melting point juga. So choose nichrome or tungsten if they ask you what wire, like how you learned in electricity last time, right? Okay, cathode. What is the function of cathode? It emits electrons after heated to high temperature. And the process I never mentioned yet is called thermionic emission. Okay, the process is called thermionic emission. And what is the definition of thermionic emission? It's emission of electrons from a hot cathode. Emission of electrons from a hot cathode. Okay, penghasilan or pengeluaran elektron daripada cathode yang panas. Okay? This one also I haven't mentioned it. To increase the rate of thermionic emission. Increase the rate of thermionic emission. How to make it more electrons coming out? 1, increase surface area. Meaning your cathode ray punya surface tadi tu, ni cathode kamu tu, dia punya surface ni surface dia. Okay, permukaan ni, you increase the area, isn't it? You make the area bigger. Because if you make the area bigger, isn't it, more electrons will be there? Okay. Second one, increase temperature. If you hotter, isn't it, electrons come out more, isn't it? Okay. Next one, surface coated with metal oxide. Okay, so this surface, you coat it with metal oxide. Reason? Because they can emit electrons at lower temperature. Meaning, once you coat it with the metal oxide, you don't have to heat it to 727 Celsius. Maybe you heat it to 600 Celsius, electrons already start coming out. Understand? Okay. And cathode, you must connect to negative terminal, isn't it? That's why I call cathode then. Negative terminal of the high voltage supply then. The EHT tadi lah. Okay. Isn't it high voltage? Right? Can? Okay. Then the beam of fast moving electrons, we also can call it as cathode ray. Correct. Okay. Properties of cathode ray. Isn't it negatively charged? Because they are electrons. Isn't it travel in straight line? They don't travel zigzag, kan? They travel straight line. Correct? They would be deflected by they will be focused by the focusing anode. They will be deflected by Y plate, X plate, but initially or originally they are moving in a straight line. Correct? And they actually produce bright spot or green spot when they strike the fluorescent screen. Understand? Okay. This picture proves that the cathode ray travel in a straight line, and also, yeah lah, it's only proving that they travel in straight line actually, okay, right? Not the first and the third one. Actually, this one is for this one. Okay, to prove that the cathode ray travels straight line. Okay, this is a very simple tube here. Okay, that only has a heated cathode. Okay, cathode yang dipanaskan, meaning electrons are flowing, that's why panas. Then anode saja, okay, right? Anode ni akan tarik elektron juga. Okay, so elektron keluar, dia akan hit this thing, okay, called the Maltese cross. This thing is called a Maltese cross, by the way, okay. In the experiment, they use a Maltese cross. Yeah? Right? Okay. Then they will see a shadow on the screen. When there is a shadow on the screen, this proves that the light actually travel. Not the light, the electrons, not the light. Sorry, tercakap salah, tersasul. The electrons actually moving straight line. That's why when they move straight line, they cannot pass through the cross. The cross blocks the electron. That's why you got the shadow there. Understand? Okay, because if they can move other way, then isn't it the shadow shouldn't be there? So this shows that the electrons are actually moving straight line, and that's why you get the shadow there. Okay, this shadow you can play around. You can make it move right, left, up, down. If you take a magnet and come, you take a magnet and come, then electrons will be moved then, because electrons will be affected by magnetic field nanti. Okay, you will learn it juga dalam last chapter, radioactivity. Okay, right, that one later. Okay, control grid, what is the function? It controls the number of electrons that strike the screen. Therefore, it controls brightness. Number 7, focusing anode for what? It focuses electrons into a beam. It acts similar to convex lens. Okay, accelerating anode, what is it for? It accelerates electrons from cathode to accelerating anode. Remember, from cathode to accelerating anode. Understand? Okay. Right? And the cathode ray travels at constant speed or constant velocity after accelerating anode towards screen, isn't it? Right? I already told you this, okay? Right? Okay. Number 9, the Y plates, the reason for it to be there is to deflect the cathode ray vertically, up and down. X plate pula deflect the cathode ray horizontally, isn't it? Fluorescent screen is to convert kinetic energy of cathode ray to light energy. Oh yeah, there's another thing that I haven't mentioned. Graphite coating. Okay? Here didn't show, but actually surrounding here all there is graphite coating. Okay? Surrounding here, this tube here. There's something called a graphite coating. Okay, and then this one connect to the earth then, the wire, earth wire. Okay, there's an earth wire there as well. This one is a symbol for earth wire. Okay, right, wire bumi. Okay, all these are graphite coating, atas dengan bawah. Okay, it's actually not atas dengan bawah lah. Based on picture nampak macam atas bawah, tapi dia sebenarnya bulat kan, dia bulat. Okay, dia round kan, dia round circular shape, isn't it? Okay, bolehlah atas bawah. Graphite coating. Graphite. Yeah, how do I spell it properly? Graphite. Okay. Somebody ask something. Wait. CRO inside is a vacuum, correct? It's in your notes nanti. I wrote it down. Okay, I wrote it somewhere here, number 12 there. It's vacuum, okay, right? But let's talk about the graphite coating first. Okay, remember the electrons when strike the screen, you got the graph, right? You get the picture that you want to see, okay? All those graph. The electrons that strike it have to go somewhere. They cannot be staying there, isn't it? Cannot be electrons datang, then continue datang, next one, ketiga, keempat, kelima, keenam, ketujuh, dan semua berkumpul kat sana. Nanti semua kat sana je. Tak mungkin, right? So dia macam ni, electrons datang, the first batch tu, dah sampai, nanti dia akan jatuh. Okay, dia jatuh. Right, dia jatuh ke graphite coating. Okay, yang lain continue datang lah. Continue datang. Understand? Then the one that tadi dah strike the screen, dia jatuh. Jatuh pada graphite coating lah. Graphite coating ni is actually, dia coat kat sini semua juga tau, understand? I just lukis kat atas bawah, okay? But it's actually coated. It's actually a conductor juga, okay? It's a conducting material. So they will conduct the electrons to the earth then. Understand? Those already strike the screen, go to the earth then. Pergi ke bumi then. Dia tak boleh kumpul kat sana banyak-banyak, understand? Okay? Nanti screen ni nanti banyak sangat elektron, nanti semua jadi terang. So therefore, they must have that earth wire and also the graphite coating to channel the electrons to the earth then. Okay? There. Graphite coating channels electron striking the screen to earth then. Okay? And then CRO is vacuum. Meaning inside got no air, okay? It's totally vacuum. Why? To prevent collision between electrons and the air molecules. Isn't it the electrons supposed to move? Shouldn't move and then collide with air molecules. Later, the result become wrong then, right? Okay, so those are all about the CRO. Now come to, okay, before we come to the graph punya part, the display on the screen, let's talk about the transformation of energy that takes place in the CRO. When you switch on CRO, isn't it electrical energy come first? After that, isn't it got heat energy? Because they heat up the heating element, the heating filament, right? Then after that, isn't it electrons start coming out? So isn't it kinetic energy? Because they start to move, agree? Then after that, isn't it when they strike the screen become light energy, correct? So this is a transformation of energy that happens inside the CRO. Agree? Okay. Now, this formula, okay, I want you to kalau you boleh ingat, kalau you hebat ingat terus macam ni lah, okay. Sebab buku biasa dia bagi macam ni, V sama dengan square root of 2EV over by M. Okay, right? Dia bagi macam ni, dia suruh hafal macam ni. Tapi susah nak hafal macam ni, okay? So I expect you hafal macam ni better. Okay, dia sebenarnya apa? It's from principle of conservation of energy. Isn't it? Energy remains the same kan? So in this case, the energy that we use going to be any of this actually, right? Sekejap lah. Okay. What I want to say just now was, the energy you can use actually any of this to get the formula. But then for sure light energy we won't use because light energy we don't learn any formula, correct? We don't learn it at all in form 4, form 5, isn't it? Kinetic energy, yes, we learn the formula, half mv squared. Heat energy, yes, we learn formula, mc theta. Electric energy, yes, we learn formula, VIT, isn't it? Vitamin E kind of thing, right? So we are going to choose this one and this one to be our formula nanti, okay, in our formula, kan? Because to deal with heat pun boleh mc theta, but then kena tahu the specific heat capacity, change in temperature semua, so tak payahlah. So we use these two, okay? So electrical and kinetic must be equal, right? All are equal, isn't it? Because principle of conservation of energy, right? This is same as this is same as this is same as this, right? Okay, but to get the formula, we just deal with these two, okay? So electrical energy, same as kinetic. So electrical energy kan VIT, vitamin E, right? Kinetic energy kan half mv squared. Careful, this V is voltage, this V is speed or velocity, isn't it? Correct? Ni velocity lah sebenarnya, okay? right? Sebab bila belajar kinetic energy ni panggil velocity, okay, right? So isn't it yang IT ni boleh tukar jadi Q kan? IT kan Q, isn't it? Charge is IT, right? Kan? But then we change this Q become small e then. Sebab E pun boleh. E is actually just charge of electron then. Kan? It's still charged, just that now specifically talking about electrons because we know electrons are moving in the CRO. So therefore, we change Q become E then. Boleh? So IT jadi E, okay? So VE ni half mv squared. Inilah formula yang saya sebenarnya nak you ingat kalau boleh. Kalau tak, you ingat electrical equals kinetic. Dapat ni. VE semua half mv squared. V is voltage, E is charge of electron, M is the mass of electron, V is the speed of the electron. Actually should be velocity, but speed also can lah because it's squared it, kan? Okay, velocity pun boleh. Okay, right? Kan? Because after you squared it doesn't make difference anymore. Plus minus still become plus, right? Because you squared the thing. So this formula can help us to find how fast the electrons is moving inside the CRO. Because mass of electrons is constant, right? Okay, charge of electron also a constant value actually. So therefore, this V squared is actually directly proportional to the big V then. Okay, the higher the voltage, the faster the electrons, isn't it? Right? If the voltage double, the speed of electron will be 4 times bigger then because got squared here. Agree? Okay. Okay. So this is the formula. If let's say got any calculation about CRO, I think number 1 terus calculation there. Notice that number 1 here. Okay. The calculation question here. Okay. Right. Nah, number 2 pun calculation. Tapi dia tanya kinetic energy. This one should be okay. Let's see number 14. Number 14 ada 4 minit. I rasa sempat ke? 14 ni 4 minit rasa tak sempat sangat. Sebab banyak benda nak cakap pasal ni. So this one haven't do yet. Okay. This one not yet. Okay. Number 15 pun not yet lah. Okay. Let's go 16 pun belum lah. Okay. Let's go number 1 sekejap. Okay. We are doing odd numbers saja sebab chapter 9. We have 3 minutes. So I need to at least do one question with you. This one nanti dulu. Okay. Next week. Boleh? Next class. Okay. In a TV, the electron gun emits a beam of electrons. The electrons are accelerated through potential difference of 10,000 volts before striking the screen. Charge for one electron is this value, coulomb. What is the kinetic energy for one electron when it strikes the screen? So, okay, kalau you tahu the kinetic energy formula kan half mv squared, right? Isn't it? Okay, so you're supposed to find the mass of the electron, and then after that this thing called the speed or the velocity of the electrons, which both also didn't give us. Agree? Dua-dua tak diberi. So boleh tak saya cakap yang benda ni sebenarnya sama dengan the electrical energy. So meaning VIT. VIT. So VIT means VE kan? IT kan tukar E tadi. Right? So meaning instead of I find mass dengan velocity, I just put big V, small e inside, then I get this answer lah. Because they are the same. So voltage, isn't it given 10,000 volts? Kat soalan. Isn't it charge of electrons given 1.6 times 10 power negative 19? Then you get your answer lah. Understand? 1, 2, 3, 4. So 1.6 times 10 power of negative 15. Okay? Right? Dah. Boleh? Understand? I repeat again, they want kinetic energy. Everybody knows formula kinetic is half mv squared. But you don't have mass of electron, you don't have velocity of electron, not given. So instead of finding this, how about we change to just use VE then? Because kinetic energy must be same as electrical energy. Electrical energy patutnya VIT, tapi IT itu juga jadi E kan? Sebab IT is Q, okay? Kan? Number 3, haven't t-shirt because of the graph, haven't t-shirt, okay? Right, so number 2 you need to do yourself. It's the same like number 1, I think. Number 3 haven't, left 1 more minute. Actually I only give you until this page. So I also expect you to do until here saja. Okay, Okay, now your trials will come very soon. So in October punya tuition, I rasa kalau tuition Friday doesn't really affect you kan, sebab next day you still don't have paper yet for Saturday. So I think in October punya class still can carry on Friday, okay, Friday night. You continue because I still need to finish off electronics dengan radioactivity then, okay, right? Can, because you still have one big exam which is SPM, okay? Right? Okay, so okay lah, that's all for tonight lah. Thank you. Okay, good night. You're welcome. Bye.